Hello everybody, Sir Beaton here, and welcome back to another past paper video. In this video, I will be tackling some measurement questions. So let's head straight into the first one. So the question says, the diagram below, not drawn to scale, shows a hollow cylinder with height 8 cm and diameter 12 cm. So it said use pi as 3.14, and they basically describe what is going on here. So let's go. The first things first, calculate for the cylinder the radius. So they want us to find the radius of this cylinder. So let me write that here. So the radius. So they told us that the diameter is 12 cm. So the radius would be half of that. So it's 12 cm divided by 2, which is equal to 6 cm. So the radius is equal to 6 cm, as easy as that. Next thing, they want us to calculate the circumference of the cross section. So the cross section of a cylinder would basically be a circle. So they want us to find the circumference of the circle. So the circumference of the circle, the formula is simply 2 pi r. So this is 2 multiplied by pi, which they told us to use is 3.14, multiplied by r, which is 6 cm. So let's punch this in a calculator. So 2 multiplied by 3.14 multiplied by 6 would give us 37.68 cm. And that would be the area of the cross section. The cross section is basically this part here. The cross section is what when you slice this thing down here, what shape you get there, that is a cross section. And the cross section for a cylinder is the same right throughout. So the next part of the question says, the rectangle below, not drawn to scale, represents the net of the curved surface of the cylinder shown above, and above would be here. So we cut this shape and we roll it out. This is what is formed. So it says, state the values of A and B. The value of A would be when we roll out this. So when we roll out this, and we cut this and we roll it out, that is what A would be. So we already found the length of this thing that is highlighted in red. We found that to be this here, which is the circumference. So we found that to be 37.68 cm. So we can say A is equal to 37.68 cm. And B would be the height. B would be the height. Remember when we open up this height will remain the same because it will just keep rolling like this. So the height will remain the same. So the height, which is B, is 8 cm. So B would be 8 cm. And it says, hence, calculate the area of the curved surface, the area of the cylinder. So the area would be, since we have a rectangle being formed, the area would be length times width. So the length would be A, which is 37.68 cm, multiplied by the width, which is 8 cm. And if we punch this in our calculator, we will get 301.44 cm squared. So the area of the curved surface area is 301.44 cm squared. So next part says, if 0.5 liters of water is poured into the cylinder, calculate to 1 decimal place the height of the water of the cylinder. So here's the thing. So 0.5 liters of water is poured into the cylinder. They want us to calculate the height. So what we need to do, we need to find something to link with the height so that we can calculate. We need to find something to link the liters of water that is poured into the cylinder and the height to find the height of the water. All right? So let's imagine this. So let me draw back the cylinder. So it says the cylinder is hollow. So that means water can be poured inside. So if you pour 0.5 liters of water, so let's say the water reaches like this height. All right, and this is the height of the cylinder with the water. So if you look at this, if we are to find the volume of the cylinder up to this piece, you know, the volume, the formula to find volume is pi r squared times the height. If we are to find the volume of the cylinder at this height, we can then find the height of the water in the cylinder if we are to find the volume of the cylinder at this height here. But do we know the volume of the cylinder? Here's the thing. They said that 0.5 liters of water is poured into the cylinder. So there's a relationship between volume and capacity. There's a relationship between liters and volume. So one thing we should know is that 1 liter is equal to 1,000 centimeters cube. So for every 1 liter, this has a volume of 1,000 centimeters cube. So if they said 0.5 liters, that means it will simply be 500 centimeters cube. So 0.5 liters has the same volume as 500 centimeters. How do we get this? We simply get this by basically multiplying 0.5 by 1,000, and this will give us 500, but there's no need to do that. If 1 is 1,000, then half would simply be 500. Common sense. So this here is the volume of the cylinder at the height that the water reaches. So now we can substitute this for volume. So instead of volume equal pi r squared h, we can say 500 cm cube is equal to pi, which is 3.14, multiplied by the radius. We found the radius earlier to be 6 cm. So this will be 6 cm squared. So we can say 6 cm multiplied by 6 cm multiplied by the height. So we want to find the height. When we work this out, we'll get the height at this level. So we work this out, so we'll have 500 cm cube is equal to, so we can say 3.14 multiplied by 6 multiplied by 6, that would give us 113.04 times the height would be h. So to find the height, it would be height is equal to 500 cm cube divided by, so you know this would be cm squared because cm times cm. So we multiply by height. So we can say height would therefore be equal to, we take over this here since it's multiplying. So it will be 113.04 cm squared is equal to the height. So the height would be equal to, so we have 500 divided by 113.04. The height would be 4.4232. So the height would be equal to, so they said the answer to 1 decimal place, so the height would be 4.4 cm. So we can say therefore the height of the water in the cylinder is 4.4 cm. And that is the answer to this question. And with that, this has brought me to the end of this video. I want you to use these concepts learned from these videos and keep practicing these kind of questions. So I'll see you in the next video in which I'll be tackling some more questions. Until then, take care and keep practicing.